So we get 29 minus 5x over 5 plus x here, sorry, plus here. 5 plus x equal to 2 over 5. How do we get 29 minus 5x? Remember that we make here as a same denominator, so we get this 15 minus 5x plus 14 divided by 2, then divided by 8 minus 3, which is 5 plus x divided by 2. So 29 minus 5x, our 5 plus x divided by 2. And then you cross multiplications. You can solve here. 29 minus 5x, you multiply by 5, and 2 you multiply by 5 plus x. So we get 29 times 5. What is 39 times 5? The value of
145.
145 minus 25x equal to 10. 2x. Sorry, 10 plus 2x. Then minus 25x minus 2x equal to 10 minus 145 minus 27x equal to minus 135x, the value of 5. So you get the value of x is 5. The value of x is 5. Any questions? You see this question is combinations about inverse function and also composite functions. For part A, we need inverse function. For part B, we have to know the compositions of functions.
Sir,
Yes.
I don't understand part where 5y plus 7 over 4 minus y.
Because we put minus outside.
Oh,
We just put minus outside. Let's say we have another functions. Three times x plus 1 square, provided that x less than minus 1, then find this, find f inverse. find the f inverse and sketch the graph of fx and its inverse on same axis. Sketch the functions and its inverse on same coordinate plane or same xy same axis. So we can say the same of xy plane. First, we need to find the inverse function a. Let y equal to 3x plus 1 square. So we rewrite x in terms of y, 3x plus 1 square equal to y, x plus 1 square equal to y over 3, x plus 1 is cube root of y over 3, x plus 1 is a square root, sorry, square root. In front, square root is plus and minus. So which one do we choose, either plus or minus?
Minus.
Minus, because the sign is minus here. So minus square root of f of y over 3. X is minus square root of fy over 3 minus 1. This is inverse function. This is inverse function. So inverse function is minus square root of x over 3 minus 1. Right. That is the fx. Fx is square root of x minus 3 over 1. Part B is sketching x, y. Fx, the function, fx is the functions of what? The functions of what? When we want to sketch the graph, we want to sketch the graph of what function?
Quadratic.
Quadratic. Is that open up, open down?
Up.
Up.
Open.
Up.
because x is positive. And where it start, it will stop at -1. And look like this. Where these 2 points here? Where those 2 points? Where is those 2 points? Where those 2 points there? Can you find those 2 points there? Yeah, -1 and 1. Right. But remember that x is from -1 and below, therefore -1 and below, so we have to remove this part. So only this, the functions of fx, the graph of the functions of fx. Start with -1. The graph of the inverse of function, inverse of function. This is inverse of functions. And the graph of the inverse of functions.
Curve graphs.
Huh?
Curve graph.
When we talk about transformations, we just start with the graph of what? When we want to sketch using transformation. But here don't relate to transformation, right? If let's say we want to sketch using transformation. Huh? We have to start with the what function?
Square function.
Square root, not square function, square root function. Square root function for this. But we have to multiply with 1/3, and then we have to move down 1 unit. And Before that, we have to reflect. So it's like that. This. It does look like this. So start with my 1 here. And then we go down. We go down how many? 1 unit. So we have to go down. So sorry, start from here, but we have to go down. It's like this. Start with 0, but we have to go down. Why we have to go down? Because this. Why go to this direction? Because of the reflection. This is the graph. The graph of F inverse. The shape of the graph for the F inverse. And if you look at the graph, they reflect each other with the line y equal to x. Reflections. About line y equal to x. Questions?
Sir,
Yes.
the question said we have to sketch
Mm-hmm.
fx and f negative of x on same axis.
Mm-hmm.
Why you sketch on x axis and y axis?
Uh-huh. The exercise in where is it?
But the question said on same axis.
No, same exist, same exists.
Oh,
Same exists mean that to be honest, x, y exists. Meaning that not sketch one graph and then another graph on different axes. Must be on same.
Right here.
Okay. Right. Chapter 2 up till here. Chapter 2. Quiz, open book test for this chapter will be next week. Will be next week. I will let you know which day we will going to do open book test. Open book test. Durations of open book test. Will be 30 minutes. If quiz last time 40 minutes, open book test will be 30 minutes. And open book test 2, we're going to focus on chapter 2, this chapter. Open book test 1, we're going to focus on this chapter. Chapter 2. And now we move to new chapter. Chapter 3, polynomial and rational. Functions. Which we are going to focus on two more functions, polynomial functions and rational functions. Now, first we look at the polynomial functions. First we look at the polynomial function. When we see polynomial, general form of polynomial function. Let's say polynomial function represented by px, a, n, x to the power of n plus a n minus 1 x to the power of minus 1 plus until the last one is a 0. Until it stops at a0, the first one is an x to the power of n. This is the general form of polynomial. General form of polynomial. Right? Remember the a1, an minus 1 until a0, they are constant. They are constant. an minus 1 until a0, they are constant. And n is non-negative integer. N must be non-negative integer. If the value of negative, this is not represent polynomial. So to be polynomial must be positive or non-negative. Non-negative, 0 considered as non-negative. So that's polynomial. An here, an an is called leading coefficient. The first one, leading coefficient. And A0 is called constant coefficient. Why constant? Because it will not change. Same throughout. Constant coefficient, and this one leading coefficient. Constant because always leading coefficient because the first one. That's the general form of polynomial functions. When we look at the function in this form, that function is represent polynomial. Easy. I want to know is polynomial? Must fulfill these requirements. If you fulfill this requirement, polynomial. So polynomial can be divided either to be monomial, binomial, trinomial, etc. Depends on the degree of n. N must be non-negative integer. And here represent the degree of polynomial. And also degree represent degree of our polynomial. So degree of polynomial, what is the degree of this polynomial? Look by the value of n. For instance, one polynomial. For instance, 3x to the power of 5 minus 2x to the power of 3 plus 6x. For example, this is polynomial? Is that polynomial? Is that px is polynomial? Is that polynomial for px?
No, sir.
Why? Why no?
Because the it is not minus by 1. Because, you can see that 1 5, the next one is 3, so it not minus by 1.
But this is general form. Does not matter minus by 1 or minus by 1. General form. This is only the general form.
Oh, okay. So it is polynomial.
It's polynomial. In this form, not necessarily that minus by 1 and then minus by 2. No, not necessary. So it is polynomial an. What is an in this case? What is an? An. What is the value of an? An.
3.
3. What is a naught? A naught, which is constant. A naught is constant coefficient. The coefficient is 3. A naught a naught.
0.
0. because it is like the plus 0 here. Seem like the plus 0, but we did not write. So 0 is a constant coefficient. What is the degree of this polynomial? Degree of this polynomial.
5 and 3.
Only one degree, right? 5. Degree is 5. N here represent degree of polynomial. 3 is not N. 3 come under this, but this is not actually the N minus 1, right? N. Okay. It's like that we write that 3x to the power of 4 plus 0x to the power of 4 minus 2x to the power of 3 plus 0x to the power of 2 plus 6x plus 0. It seems like this. Another way to write. So that we can see that if it's equal 5 and then 4, then 3, then 2, then 1. 6x is 6x to the power of 1. But we do not write that. We do not write this. And we do not write this. We do not write this. That's why we're going to have only 3x power of 5 minus 2x power of 3 plus 6x. But in fact, they're there. Only they disappear. We cannot see them. Let's say another px minus x to the power of 8 plus 2x to the power of 6 plus 9x to the power of 3 minus 3x to the power of 2 plus 7x minus 15. Is that polynomial? No one, we want to know whether it is polynomial or not. Polynomial or not? Is that polynomial?
Yes.
Yes. What is the leading coefficient?
Is it -1, sir?
-1. Constant coefficient? Constant coefficient.
-15.
The 15. Degree of this polynomial?
8.
8. Degree of polynomial of this polynomial is 8. Leading coefficient is -1. Yes, it is -1 multiplied by x power of 5, and -15 become our constant coefficient. This general form for polynomial. Right. I think I stop here, and inshallah we'll see you back on Monday next week. We do not have lessons on Thursday. Thursday is a public holiday. But bear in mind that This is only for mathematics. For another subjects, I do not know. You need to ask your lecturers. For mathematics, you don't have a lesson on Thursday. For other subjects, I do not know. Right. Yeah. Right. Malaysia's Day, 16th of September. Right. To commemorate the formations of this country. Right. I think I close the sessions today now with Tasbih Kifara and Surah Al-Asr. Subhanallah.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.